Okay, looking at number 9. So we are drawing the dot pattern that comes next, and we're recording the number of dots in the pattern. So we notice that we have 1 dot first, then we go to 3 dots, then we go to 6 dots. So this is going to be something like 3 times 1 pattern gets us 3, then 3 times 2 gets us 6. So if we were going to draw the dot pattern that comes next, we would say 3 times 3 rows gets us 9. Write a description of the pattern. We might say the pattern is multiplying by these. Okay. Oops. And then the question says, how do you know how many dots to add each time? We are going to simply find the next multiple of 3. I know that string of 3 each. All right, moving on to number 10, and this is a big long one. We are completing the line plot. We've got whole numbers and mixed numbers and fractions as our data. So this says, for 12 days, Carla kept track of how much each loaf of banana bread she sold at a bakery. So how many loaves, how much of each loaf of banana bread she sold. Each loaf has 6 slices. She recorded each sale to the nearest 1/6 of a loaf, and here are the results. So let's look at the data. We have 3/6. This is like she sold 3/6 of a loaf of bread. She sold 0/6 of a loaf of bread. She sold 3/6 or half a loaf of bread, 5/6 of a loaf of bread. So she almost sold that whole loaf of bread. She sold 1 2/6 loaves of bread. So this time she sold 1 whole loaf plus 2/6 of another. So it's always important to make sure you understand the data that you are actually looking at in order to complete a line plot. So if we were going to create a title for this, we might say something like loaves of bread sold at Carla's Bakery. We're looking back up in this text here to come up with a really good title. Loaves of bread. This is italicize our words too. Sold at. Nice title, I think. Everyone will know what you're looking at, what they're looking at as far as a data line. Okay, then the next step here is to plot our data. We are going to look up at all of our numbers up here, our fractions, and we're going to look for the minimum fraction. So I notice that there is a 0 here. That's where we need to start. That's the least amount. And then everything goes by sixths. So we will just go up by sixths. We don't want to look up at the data anymore because we're not only plotting the data that's listed up there. We need to create a true number line. So we're going to list every number in order, every fraction in order until we run out of spaces below. That's going to ensure we have every space available to plot our data. So we said this minimum amount here was a 0. And then we're going to go by sixth. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, or 1, and I'm actually going to make this 1 whole since I have a whole number of 0 down there. 1 1/6, 1 2/6, 1 3/6. Now that I've run out of space, I'm going to look back up at my data and just make sure that there is no data greater than 1 3/6 up there. I see a 1 3/6. But I do not see anything greater. So I'm good to go on my number line. So what are those fractions that we just listed? We need to create a label below to describe what those fractions are that we did. So we said that the fractions are slices of a loaf, I would say slices of a loaf by sixes each, sixth to the nearest sixth. Okay, so let's put that. Slices of a loaf, this in parentheses. Hey, you know what? Let's just say loaves of bread to the 1/6 of a slice. I think that's better. Loaves of bread to the nearest 1/6 of a slice. And the reason I think we should switch that to loaves of bread there is just because we've got some of our data here being greater than 1 loaf. So we need to show that this is like 1/6 of a loaf, 2/6 of a loaf, but then we get all the way up to the 1/6 of a slice, which explains how come we have 1 and 3/6 as our greatest number. All right, now we're going to go back. When you plot your data on a line, you have to use X's, and my suggestion is to just go in order and X it out after you plot it. So I see 3/6, X there, cross it out. I see 0, put an X above it, cross it out. I see 3/6, put an X, cross it out. 5/6, put an X, cross it out. 1 and 2, 1 and 1/6, 4/6, 1/6, 5/6, 5/6, 1 and 1/6, 1 and 3/6, and there I'm done with my data. So next I'm going to use my data to answer some questions below, and I'm going to skip over to the next page here. Question says, how many days did she sell 3/6 of a loaf? So I'm going to look over here and see how many times I logged 3/6 of a loaf. She logged it 2 days. How much of a loaf is this all together? We know that she did 3/6 of a loaf 2 days, so I'm going to do my whole number, 2 days times 3/6. 2 times 3 is 6. 6/6 is 1 whole, so she sold 1 loaf altogether. Letter C, what's the greatest amount of banana bread Carla sold on any day? So if we look back at our data, we know one day she sold 1 3/6 loaves of bread, which is awesome. What amount was sold most often? I'm going to go back and see which amount I have the most X's above. 5/6 of a loaf was the greatest. And then what difference between those two amounts? The greatest amount she sold, the amount she sold most often. So we're going to subtract 1 3/6 minus 5/6. Now this is tricky because we know we can do 1 minus nothing for whole numbers, but then we can technically not do 3 minus 5. So we're going to have to do a little bit of converting first. One way I suggest converting is to take our mixed number and turn it into an improper fraction. This is going to be the simplest choice in this case. So we're going to take 6 times 1, take our denominator times our whole number is 6, plus 3 is 9. So now we have 9/6 minus 5/6, which gets us 4/6 as the difference. Okay, I hope this helps you guys. Study the whole study guide tonight, and you will do extremely well on your Unit 7 math test tomorrow. Thank you for